All right, we're still looking at more identities. So this is the half angle identity. We can find them on page 348. I also have them listed here for you. We're going to use these mainly for two scenarios. We're going to use them if we're trying to find the exact value of something that isn't on the unit circle, but the double of that value is on the unit circle, and then we'll use them to solve. So let's start by looking at two examples where we're trying to find an exact value. So if they say exact value, again, that means don't round it, so I don't want to use my calculator. And 22.5 is not on my unit circle. But if I think about what is 2 times 22.5, well, that's 45, and 45 is on my unit circle. So I can say cosine of 22.5 degrees is the same thing as cosine of 45 over 2 degrees. And now I can go ahead and plug that into this formula here, and that's going to allow me to use cosine of 45, which I can just find in the unit circle. So plugging into that formula, I get plus or minus, which I'll talk about in a moment, 1 plus cosine of 45 degrees all over 2. Well, remember I'm taking the cosine of 22.5 degrees, which I know is going to be a positive value because that's in quadrant 1. So I'm going to go ahead and drop the plus or minus and just take the positive. I also know that cosine of 45 degrees is radical 2 over 2 all over 2. It's weird to have that little fraction, that inside of the big fraction, so that complex fraction. So what I'm going to do is I'm going to go ahead and I'm going to multiply the top inside of this by 2, which means I would also have to multiply the bottom by 2. Doing that, the 2 on top will distribute in, giving me 2 plus, when it multiplies here, my 2's are going to cancel, so 2 plus radical 2 all over 4. And since I can take the square root of the top and the bottom separately, I can go ahead and say that this 4 underneath the radical, well, the radical of 4 is just 2. So I'm going to get the square root of 2 plus radical 2 all over 2. And I'm going to go ahead and leave that as my exact value. It's not a very nice value, but it's my exact value. And then looking at example 2. Okay, so I'm going to do the same thing as I did before because I know 7 pi over 12 isn't on my unit circle. We've already looked at a problem, I believe, using the same value where we've talked about how we can use sum and difference identities. So just another option to the sum and difference identities. I can say that 7 pi over 12 times 2 is equal to 7 pi over 6, which is on my unit circle. So I can say tangent of 7 pi over 12 is the same thing of tangent of 7 pi over 6 all over 2. And the reason that's helpful is because I have a couple different formulas for that. Well, I'm going to go ahead and I'm going to choose a formula that doesn't have a radical in it, so I'll just go ahead and choose the second formula. It doesn't matter which one you use. Doing that's going to give me tangent, not tangent. It's going to give me 1 minus cosine of 7 pi over 6 all over sine of 7 pi over 6. Well, I know that cosine of 7 pi over 6 is negative square root of 3 over 2. And sine of 7 pi over 6 is negative 1/2. Well, instead of dividing by a negative 1/2, I'm going to go ahead and multiply by negative 2, giving me 1 plus radical 3 over 2 times negative 2. When it distributes in, I get negative 2 minus radical 3. And now we'll look at one final example where we solve, and we've solved before. And so notice that I have here a half angle, and I can't combine anything. I don't have any kind of like terms because none of these are none of these are half angles. So I would like to get rid of this half angle so I could possibly combine some like terms. The other nice thing is this sine is being squared, so I know when I substitute this half angle with a radical, it's going to go away. So with anticipating all that, I'm going to go ahead and plug in my half angle formula. So I'll have 2 times sine of x over 2 is, and I'm not even going to worry about the plus or minus because I'm going to square it anyway. square root of 1 minus cosine of x over 2 squared plus cosine of x equals 1 plus sine of x. Squaring makes my radical go away, and I'm left with 2 times 1 minus cosine of x all over 2. And then the rest of my equation drops down. Now, my 2's are going to go ahead and cancel out. And I'm left with 1 minus cosine of x plus cosine of x equals 1 plus sine of x. Well, these are going to go ahead and drop to be 0. I'm also going to subtract 1, and that's going to become 0, leaving me with 0 equals sine of x. When does sine of x equal 0? Well, it happens to be at 0, it happens at pi, at 2 pi, at 3 pi. In fact, it happens every pi, so I'm going to go ahead and say x equals 0 plus pi n, or just pi n. And again, I could list both of them rather and say plus 2 pi n either way. So again, nothing new, just still expanding those list of identities we have. So once again, just bring in any questions you have with you for class, and we'll do some practice with this in class as well.